Hello everyone, welcome back to the channel. In today's HVAC training video, we are going to learn one of the most important topics in air conditioning and refrigeration, superheat and subcooling. If you're an HVAC beginner, don't worry. By the end of this video, you'll understand what superheat is, what subcooling is, why they are important, how to measure them, and how HVAC technicians use them to diagnose system problems. Many technicians memorize the formulas, but don't truly understand what is happening inside the refrigeration system. Today, we are going to make it simple and practical. Let's get started. Understanding the refrigeration cycle. Before we talk about superheat and subcooling, we need to understand the refrigeration cycle. A basic air conditioning system has four main components: compressor, condenser, coil, expansion valve or metering device, evaporator coil. The refrigerant continuously travels through these four components. The compressor compresses low-pressure vapor into high-pressure vapor. The condenser removes heat and turns the refrigerant vapor into liquid. The expansion valve reduces pressure and temperature. The evaporator absorbs heat from indoor air and turns the refrigerant back into vapor. Then the cycle repeats. To understand superheat and subcooling, we need to focus on what happens when refrigerant changes state between liquid and vapor. Let's start with superheat. Superheat is the amount of heat added to refrigerant vapor after all the liquid refrigerant has completely evaporated. Let's imagine refrigerant inside the evaporator coil. As warm air passes over the evaporator coil, the refrigerant absorbs heat. The liquid refrigerant starts boiling and changing into vapor. At a certain point, all liquid refrigerant becomes vapor. If the refrigerant continues absorbing heat after becoming a vapor, that extra temperature increase is called superheat. Simply put, superheat is extra heat added to refrigerant vapor after complete evaporation. Why is superheat important? The compressor is designed to compress vapor only. If liquid refrigerant enters the compressor, serious damage can occur. Liquid cannot be compressed. This condition is called liquid floodback or slugging. Superheat ensures that only vapor refrigerant returns to the compressor. Think of superheat as a safety zone that protects the compressor. Without proper superheat, compressor failure can happen. That is why HVAC technicians always check superheat during troubleshooting and refrigerant charging. How to measure superheat? Now let's learn how technicians measure superheat. Step 1. Connect gauge. Connect the low side gauge to the suction service port. This is usually connected to the larger copper pipe. Step 2. Read suction pressure. Suppose your gauge reads 118 pounds per square inch on an R410A system. Step 3. Convert pressure to saturation temperature. Using an R410A pressure temperature chart, 118 pounds per square inch corresponds to approximately 40 degrees Fahrenheit saturation temperature. Step 4. Measure suction line temperature. Use a clamp thermometer on the suction line near the outdoor unit. Suppose the temperature reads 52 degrees Fahrenheit. Step 5. Calculate superheat formula. Superheat equals actual suction line temperature minus saturation temperature. 52 minus 40 equals 12 degrees Fahrenheit. Therefore, the system has 12 degrees of superheat. What does low superheat mean? Low superheat means refrigerant is not completely evaporating before reaching the compressor. Possible causes include overcharged system, expansion valve feeding too much refrigerant, dirty evaporator sensor, poor TXV control. Low superheat can cause liquid refrigerant to return to the compressor. This is dangerous. What does high superheat mean? High superheat means the evaporator is starving for refrigerant. Possible causes include low refrigerant charge, refrigerant leak, restricted filter dryer, blocked expansion valve, dirty evaporator coil, low airflow, High superheat causes poor cooling performance and can overheat the compressor. What is subcooling? Now let's move to subcooling. Subcooling is the amount of heat removed from liquid refrigerant after it has completely condensed. Let's understand this clearly. Inside the condenser coil, hot refrigerant vapor releases heat to the outdoor air. As heat is removed, refrigerant changes from vapor to liquid. After all vapor becomes liquid, the condenser may continue removing more heat. That extra cooling is called subcooling. Simply put, subcooling is extra cooling added to refrigerant liquid after complete condensation. Why is subcooling important? The expansion valve needs a solid column of liquid refrigerant. If vapor bubbles are present in the liquid line, the metering device cannot properly control refrigerant flow. Proper subcooling ensures stable refrigerant flow, better cooling performance, improved efficiency, accurate refrigerant charge. Subcooling confirms that enough liquid refrigerant is reaching the expansion device. How to measure subcooling? Let's calculate subcooling step by step. Step 1. Connect high-side gauge. Connect your gauge to the liquid service valve. This is usually connected to the smaller copper pipe. Step 2. Read high-side pressure. Suppose the pressure is 360 pounds per square inch on an R410A system. Step 3. Find saturation temperature. According to the PT chart, 360 pounds per square inch equals approximately 110 degrees Fahrenheit. Step 4. Measure liquid line temperature. Use a clamp thermometer on the liquid line. Suppose the actual temperature is 98 degrees Fahrenheit. Step 5. Calculate subcooling formula. Subcooling equals saturation temperature minus liquid line temperature. 110 minus 98 equals 12 degrees Fahrenheit. Therefore, the system has 12 degrees of subcooling. What does low subcooling mean? Low subcooling often indicates low refrigerant charge, refrigerant leak, insufficient refrigerant in condenser. Symptoms may include reduced cooling, high superheat, low suction pressure. What does high subcooling mean? High subcooling often indicates refrigerant overcharge, restricted liquid line, blocked filter dryer, condenser flooding. Symptoms may include high head pressure, reduced efficiency, increased power consumption. Superheat versus subcooling. Let's compare them. Superheat, measured on suction line, indicates evaporator performance, protects compressor, deals with refrigerant vapor. Subcooling, measured on liquid line, indicates condenser performance, ensures proper liquid supply, deals with refrigerant liquid. Easy way to remember: superheat equals vapor side, subcooling equals liquid side. Thank you for watching. If you found this video helpful, please don't forget to like, comment, and subscribe for more HVAC tips and tutorials. Your support helps us create more useful content for you. Thanks for being here. Compose right to technology advance.